Thus far in this unit, we've taken very good care to not be using our calculators with these matrices that we've been solving. The reason this was very intentional, part of the test is no calculator. So up till now, everything you should be able to do without the calculator. What we're going to start seeing today, though, is how to actually use the calculator to help us manipulate matrices that are going to be a little more difficult to work with, or where we don't want to get bogged down with the steps of simplifying the matrix. So what we're doing today is going back over everything we've covered, but how to do it on the graphing calculator. This is matrices on the TI 8384 calculator. First thing we want to look at is how we do some matrix operations. And to do these matrix operations, first we're going to look at how we can actually program matrices into the calculator so that we can use them. So we're going to program 3 matrices into the calculator. Matrix A is going to be a 2 by 2 matrix, 2, 3, -1, 4. Matrix B is going to be a 2 by 3 matrix. It's going to be 3, -2, -5, 1, 6, 2. And matrix C is going to be a 2 by 3 matrix, 4, -1, 3, 0, 1, -1, 5. And as I wrote these, I mentioned their dimensions. That's going to be very important that we know the dimensions of each matrix before we program it into the calculator. Matrix A has 2 rows and 2 columns. Matrix B has 2 rows and 3 columns. Matrix C has 3 rows and 2 columns. Those dimensions are going to be important. So let's see if we can take a look at the calculator. I'm going to move it over here so it's kind of out of the way. Hopefully we can see everything we need to see on it. Where we get the matrix from is right above the x inverse x -1 button. You see in blue it says matrix. So we're going to hit second and then the x inverse button, which takes us to the matrix menu. First, we have to program in these matrices. So we're going to scroll over to where it says edit to edit our matrix. And the first matrix we're going to edit is matrix A, as listed here. So we'll hit enter on matrix A. And it wants to know how big this matrix is. A is a 2 enter by 2 enter matrix. It gives us then a 2 by 2 matrix that we can fill in by hitting enter after each entry. So we'll go 2 enter, 3 enter, -1 enter, 4 enter. And now matrix A is that 2 by 2 matrix. To get back to the main menu, we have to quit out of this screen. We'll hit second, and right above the mode, you'll see it says quit. And that'll take you back to the home screen. Now we're ready to program matrix B in. We'll hit second, matrix. Notice matrix 1 shows that A is a 2 by 2 matrix. That's good. That's the one we've already programmed in. We're going to scroll over to edit and scroll down. This time we're going to edit matrix B. B is a 2 by 3. So we do 2 enter, 3 enter. And there we've got the values 3, -2, -5, 1, 6, whoops, 1, enter, 6, enter, there it goes, 2. And there's our 2 by 3 matrix. Back to the main menu with second quit. And we can program matrix C into the calculator, hitting second matrix. Now we see the 2 by 2 and the 2 by 3. We're going to scroll over and edit a third matrix. Matrix C is going to be a 3 by 2 matrix. 4, -1, 3, 0, -1, 5. And then hit second quit. And now we've got all three matrices programmed into the calculator. So now we can actually do some operations with these matrices. Let's say I want to take A times B, and then I want to subtract 2 times B for a matrix. That's really easy to do on the calculator now. We hit second matrix. Select first matrix A under names. This time we're going to use it. Enter. Times B, second matrix. Scroll down to matrix B. Enter. Minus 2 times matrix B again. So second matrix, matrix B again. So that's AB minus 2B, and when I hit enter, it gives us this nice little matrix. That is the solution we get from multiplying, scalar multiplying, and adding. 3, 18, 6. 3, 18, 6. -1, 14, 9. -1, 14, 9. And so that's how easy it is to do matrix multiplication, addition, and subtraction on the calculator. We can even find an inverse matrix really quick. Let's try and find A inverse. This matrix is really easy to find on the calculator. We grab matrix A, second matrix. Matrix A is number 1. And the inverse button is the x to the -1 power. That finds the inverse of the matrix. And when I hit enter, it's going to give me the inverse of matrix A, which is an ugly, ugly decimal. We can scroll over to see all the ugly decimals of all the values. With matrices, we generally do not prefer the ugly decimals. So we're going to look at how we can change those ugly decimals into pretty fractions. Under the Math menu, right beneath the alpha, you see frac. If we hit enter, it's going to take the previous entry and change it into fraction form, which is really nice. And there we go, 4/11, -3/11, 1/11, and 2/11. That is the inverse of matrix A. So we had 4/11, -3/11, 1 and 2/11, 1/11, and 2/11. And that is, clean that up a bit. And that is our inverse matrix. Much easier than going through the process we went through yesterday. In fact, if it's so easy to find an inverse matrix, it should be really easy to solve a system of equation using these matrix operations. Let's solve x plus 2y plus 3z equals 9, 3x plus 4y plus z equals 5, and 2x minus y plus 2z equals 11. Now if we were to convert this to AX equals B formation, matrix A would be the coefficient matrix 1, 2, 3, 3, 4, 1, 2, -1, 2, times the variable matrix x, y, z equals the solution matrix 9, 5, 11. And right now this is all set up as AX equals B. But we know that if we left multiply by A inverse, x is equal to A inverse B. So on the calculator, if we program matrix A and B, we can find out what A inverse B is really quick. So let's do that. We're going to go second matrix, and we're going to reprogram matrix A, edit matrix A. We no longer want a 2 by 2 matrix. Now we want a 3 by 3 matrix with 1, 2, 3, 3, 4, 1, 2, negative 1, 2. So that's matrix A. Second quit. Now we have to program the new matrix B. Second matrix. Go over to edit. Scroll down to matrix B. The new matrix B has 3 rows and 1 column. It is 9, 5, 11. Second quit. Back on the home screen now, I just have to have the calculator tell me what A inverse B is. Because it already knows A, we just hit second matrix. Grab the first matrix, matrix A. Use the inverse button. And then second matrix, matrix 2 is matrix B. And so we type in A inverse B on our calculator and hit enter, and it's going to give us the 3 solutions to this system of equations. 2, negative 1, 3. Two, negative 1, 3 is the solution to this system of equations. That's not the only thing we can do with our calculator, though. We can also do row operations. Now with row operations, we do need to make sure we know the correct notation that we are going to type into our calculator. So the 3 operations that we can do are we can swap rows, we can multiply rows by reciprocals, and we can multiply a row by an opposite and add it to another row. So we need to know how to do all 3 of those things on the calculator. So the first one I want to do is how you swap rows. There is a feature in the calculator called row swap. And it opens the parentheses. In row swap, we're going to enter the matrix that we want to swap, that we're working with. And then we're going to type in the 2 rows that we want to swap with each other. So for example, if we wanted to maybe swap row 1 with row 2, this is how we've been writing it so far, what we would type in the calculator, say we're talking about matrix A, is we will type row swap, and then select from the matrix menu matrix A, and swap rows, whoops, well that would work too, but swap rows 1 and row 2, and close the parentheses. That's one feature on the calculator. The next one on the calculator is if we want to multiply a row by something, you get times row. With times row, we're going to say what we're going to multiply by. We're going to say what matrix we're going to multiply by, and what row is going to be multiplied. So for example, if we wanted to do 3 times row 1 and insert it into row 1, actually let's even make it 1/3 because they're usually fractions. 1/3 times row 1 to get a new row 1, what we'll type in our calculator is our times row. We're multiplying by 1/3, comma, the matrix. Just for conversation, we're going to say matrix A. And the row we're multiplying is row 1. Actually, it's not a square bracket. It's That's a curved bracket. And that'll multiply the row by the number. The final operation is to multiply a row by something and add it to another row. And the way we do this is we are going to say what we're multiplying by, what matrix we're multiplying by, then we will list the pivot row, and then the new row. So for example, if we wanted to take 2 times row 3 and add it to row 1 to get a new row 1, what we will type is the multiply row add feature, then what we're multiplying by, which is 2, the matrix, which we're going to say A. We actually are going to use previous answer most of the time. The pivot row is the 3, and the new row is row 1. And that'll multiply 2 times matrix A's row 3 and add it to row 1. Notationally, that takes a little bit to get used to, but once you do a few examples this way, you kind of start to memorize these 3 row operations that you can do on a calculator. They're going to be very important because in our next couple lessons, we're going to look at some applications of matrices. And as we do that, we're going to use these row operations to help us simplify and solve problems. So let's take a look at that same systems of equations that we solved up above with the A inverse B thing. That x plus 2y plus 3z equals 9, 3x plus 4y plus z equals 5, and 2x minus y plus 2z equals 11. And instead of solving this by finding A inverse B, we're going to do our row operations to get it into reduced row echelon form. If you remember, we did that by making an augmented matrix with the coefficients and the solutions. 1, 2, 3, and the solution was 9. 3, 4, 1, and the solution was 5. 2, negative 1, 2, and the solution was 11. Now, we are going to do this all on the calculator, but I do want to stress, I still need you to show me what you're doing on the calculator. So I do want you to write down all the steps. You just don't have to write down the math. The calculator is going to do the math. So again, we see the 1 that we already want there. Next, we need zeros below. So what we're going to do is we're going to multiply negative 3, the opposite, times the pivot row 1, add it to row 2 to get our new row 2. We're also going to do negative 2 times row 1 plus row 3 to get the new row 3. And that's going to give us a new matrix. The first row is going to be the same, 1, 2, 3, 9. The second and third row, though, we're going to have the calculator do the ugly work for. So, first we need to program this matrix in. So we'll go second matrix, and we'll go over to edit it. We might as well stick it in matrix A. Notice each matrix is saved until you delete it and replace it with a new matrix. And that's okay. There's no reason to reset it. We need a matrix with 3 rows and 4 columns. The original matrix was 1, 2, 3, 9, 3, 4, 1, 5. Oops, 1, 5. I said 15. 1, 5, 2, negative 1, 2. Oops. 2. Come on. Doesn't want to go to the next cell here. Enter. There it goes. 2, 11. Then we'll say second quit. And then what I usually do is I try and stick that matrix on the screen. So I'm going to hit second matrix A, which is the matrix we just programmed. And then I'm going to hit enter so I can look at it on my screen. Make sure I typed it in correctly. It does match the matrix we wanted. So now we're ready to do some manipulations with this matrix. So we'll hit second matrix. And you notice the middle menu that we haven't used yet says math. Scroll over to math. There's a lot of options here. We want some of the options off of the bottom. If you scroll up one from the top, it'll take you all the way to the bottom. And you'll see the very bottom option is to multiply a row by something and add it to another row. First, we're going to say what we're multiplying by. We only can do one row at a time. So we're going to first multiply by -3, just like we just wrote on our screen, comma. Then we have to tell it the matrix we're using. We're going to tell the calculator to grab the previous answer. So we'll hit second answer, comma, the pivot row, which is row 1, comma, the new row, row 2. And close the parentheses. When we hit enter, you'll notice we got the 0 in that spot underneath the 1 that we wanted. Now we're ready to do the third row. So hit second matrix. Whoops. Helps to hit second first. Second matrix. Go over to math. Scroll up so that we can multiply by something and add it. We're going to multiply by -2 times the previous answer, second answer, comma, the pivot row is row 1, comma, we're adding it to get a new row 3, and hit enter. And there we have a 1 with 3 zeros under it. So I'm going to do it in columns. That's not standard, but helps me type it in here. -2 and -5 in the center column. -8 and -4. And -22 and -7. So now that gives us that 1 with all the zeros underneath it. Next we need a pivot in the middle. We're going to multiply by the reciprocal. The reciprocal of -2 is -1/2 times row 2 and stick it into row 2. Notice I'm writing everything I'm doing. I'm just having the calculator do the math for me. To do some math, we're going to hit second matrix. Go over to do some math. And actually, I'm going to scroll up 1. This time, we're just multiplying a row by something. You notice that's the one right above it, times row. Make sure times row is selected. We say what we're multiplying by, which is -1 divided by 2, comma, the matrix we're talking about, which is the previous answer, comma, and the row we're multiplying, the second row. Close the parentheses and hit enter. And now we've got our new matrix with the 1 in the pivot that we want. So it looks like it's 1, 4, 11 in the new row. So the top row's unchanged. 1, 4, and 11 in the new row, and the bottom row unchanged. Make sure I got that typed in there right. Yes. So now we're ready to get zeros above and below. It's going to be 2 steps on the calculator. We'll write it as 1 step on our paper, multiplying the pivot row by the opposite. So we have -2 times row 2 plus row 1 is the new row 1. In the bottom row, the opposite of -5, +5, times row 3, times row 2, plus row 3 is the new row 3. Typing those in one at a time, we hit second matrix. Go over to math. We're going to times row plus. We're going to take -2 times the previous answer in row 2 and stick it into row 1. Close the parentheses. Notice that gave us the 0 on top that we wanted. Second matrix, math. Scroll up to grab times row plus. This time we're doing 5, comma, times the previous matrix, comma, in row 2, comma, added to row 3. Close the parentheses. And that's going to give us a new matrix with a 0 below. So let's copy that down. So the first column is 1, 0, 0. Now we have 0, 1, 0. The next column, -5, 4, 16. -5, 4, 16. And then the next column, -13, 11, 48. And now we're ready to get the last pivot. To get the last pivot, we have to multiply by the reciprocal. We're going to take 1/16 of row 3 and stick it into row 3. So we're just multiplying, not adding. So we're just going to do the times option under math. One more up is multiplying a row. We're going to multiply by 1/16, comma, times the previous answer, comma, in row 3. Close the parentheses. And that's going to give us our new row 3. Notice it's got the 1 we want in the pivot point. So 1, 0, -5, -13, 0, 1, 4, 11, 0, 0, 1, 3. Make sure I copied that right. Good. So now we're ready to get 1s everywhere else. And the way we're going to do that is we're going to multiply row 3 by the opposites. So first we've got 5 times row 3 plus row 1 to get our new row 1. We've also got -4 times row 3 plus row 2 to get our new row 2. And let's see what that gives us. Second matrix, go over to do some math. To multiply and add, we're going to take 5, comma, times the previous answer, comma, times row 3, comma, and stick it into row 1. Notice that put the 0 on top. That's good. We're going to do some more math with it. Do the second part. Times row plus. This time we're multiplying by -4, comma, times the previous answer's matrix, comma, in row 3, comma, and we're going to stick it into row 2. Close the parentheses. Hit enter. And there we have our reduced row echelon form with 2, -1, 3. 1, 0, 0, 2, 0, 1, 0, -1, 0, 0, 1, 3. And off of this we can see our x, y, z, the same answer we got before using A inverse B, 2, -1, 3. The comment I get here is often, hey, that is a lot more work than just doing A inverse B. Why do we need to know how to do that? Well, here's why you need to know how to do that. Because we are going to be using row operations to do something different. It's called the simplex method, to maximize or minimize some problems. And we aren't actually going for the same solution per se. We aren't actually going for 1s down the diagonal. and so we won't be able to use the A inverse B in the future. You do need to know how to do the row operations on the calculator when we get to that point. But for now, we're using row operations to get to that reduced row echelon form. Reduced row echelon form has those ones down the diagonals and zeros everywhere else. Which brings up an interesting question. If reduced row echelon form is so popular, can't the calculator just do reduced row echelon form? It can. It has an RREF, or reduced row echelon form, and it opens a parentheses where you can put in the matrix. And so I just want to show you how that would work with our system of equations that we've been playing with today. X plus 2y plus 3z equals 9. 3x plus 4y plus z equals 5, and 2x minus y plus 2z equals 11. Now again, if we know we want to solve by reduced row echelon form, we can make the augmented matrix 1, 2, 3, 9, 3, 4, 1, 5, 2, negative 1, 2, 11. And we're going to find the reduced row echelon form on the calculator. Normally we'd have to program this matrix in, but remember matrix A that we programmed at the beginning already is that matrix. It's the same problem we just did. I would put it on the screen just to verify that those numbers are all correct. They are. So now we're going to hit second matrix, scroll over to math, and depending on the type of calculator, you might have to scroll down farther or less far. It might be put in a different spot. Notice there is an REF, that's row echelon form. There's our REF, that's the one we use, reduced row echelon form. Make sure you've got the RR. And we'll take the second answer, the answer just above it, the matrix just above it, and when we hit enter, you see we get the exact same matrix that we got above doing row operations, the identity with 2, negative 1, 3. So we get 1, 0, 0, 2, 0, 1, 0, negative 1, and 0, 0, 1, 3, which implies yet again that the answer is 2 for x, negative 1 for y, and 3 for z. So, just to repeat, you do need to know how to do all of this stuff without the calculator. Part of the test will be without the calculator. That's why we've put off the calculator until now, when we're going to start to see the calculator portion of the test. When we get to the calculator portion of the test, you do need to know how to do all of these operations. That includes your basic operations, programming a matrix into the calculator, finding an inverse, doing A inverse B on the calculator to find a solution, how to do the 3 different row operations. You need to be familiar with those. And then finally, if you want to learn how to use the reduced row echelon form feature on your calculator, that also is quite nice. The assignment today is to go back to the previous 4 sections that we've been looking at and go through those, see if you can do those with your calculator. Hopefully you get the same answers you got earlier this week. And come to class with questions, and we'll get really good at using these calculators so we can get to some of the interesting examples and uses of matrices. See you then.